Yes, thank you. So hello, everybody. Hello, world. My name is Stefan Sørenes, and my role is being a leading advisor within industrial IT in Equinor. So today I will talk about how we utilize OPC UA to become data-driven in our company. So data-driven operations, that is actually one of the focus areas and programs we have in our digital roadmap in Equinor. And I guess many books and articles have been written about what data-driven operations mean in practice. But from my perspective and in my opinion, to achieve data-driven operations, you simply need four things. First of all, you need data. You simply need data to be available if the ambition is to run your business based on data. And the challenge in Equinor and many other industrial companies today is that the data is very tightly coupled to the data systems, the applications, where each application have their own interface, their own data model, their own formats, their own way to access the data, etc. The second thing we need is context. So data without any context is quite useless. That is our experience. So you need some additional context to ensure that both humans, but also machines and software can understand what the data means in order to use it, in order to act upon it. So only data is not enough. And when you have data and you have the data in the context, then you have information that you can start to utilize and act upon. Then we need to make that available to humans, to machines, to software for usage, for analytics, visualize it, use it for optimization, etc. And the last step is business decisions. So the final step is to actually make business decisions, make faster decisions, better decisions based on the insights derived from the information or the analyzed data. And OPC UA is a connectivity framework for industrial automation data that is really supporting and helping us to make contextualized data available from the industrial assets and the automation and control systems that we have around our facilities. So OPC UA is here to give us data, but also context. That is the key thing with OPC UA. And time series data and sensor data made available from all these industrial assets and field devices we have on the facilities and make this available to the IT world, to the IT platform for monitoring, analytics, optimization, decision supports, etc. They have in the past been very simple. It's simply a name, a tag name, it's a value, it's a quality bit and a timestamp. And if you are lucky, you get some additional metadata as well, such as a description and unit, but that is not always the case, actually. But what we see is that this simple sensor data is quite useless without any additional context. You probably know that this is data measuring something, but what exactly does it measure? Some people with years of hands-on experience from a particular facilities or facility system, they will know what this data means just by looking at the name. But for many people and subject matter experts in the business and support centers onshore, this simple data doesn't make much sense, actually. So we see that both humans and software, they need additional context in order to make this sensor data actionable. And so sensor data combined with the right context is giving us the information that we can start to act upon. So the most powerful game changer in OPC UA, in our opinion, is the information modeling framework. It is the way OPC UA achieves interoperability. So the ability in OPC UA to actually transform data into information using the embedded modeling framework, and also the ability that different companies can join forces and standardize the information we put into these OPC UA servers by using standardized OPC UA information models. That is simply what OPC UA is about. It's not about moving some bits from A to B anymore. It's about achieving interoperability to ensure that humans and software can understand the data and use the data. So OPC UA, as an open, international, industry independent and secure connectivity framework, as I mentioned, is supporting us to make real-time information available, which is the 2 out of the 4 pillars to become data-driven. But to do that with scale and speed, we need interoperability. And our facilities today, they are heterogeneous, meaning that we have many assets delivered by many different vendors, delivering software and hardware on the same facilities and across facilities. And if each company out there is delivering the same type of data in different vendor and system-specific interfaces with vendor and system-specific information models and semantics, then we humans, our engineers, our experts, they need to spend more time on this data plumbing that has been mentioned, more time on interpreting, mapping, transforming, and preparing the data than actually using the data to drive business value. So therefore, interoperability is important for scale and speed in Equinor. So with OPC UA, you can have servers and connectivity looking like this, an object-oriented address space giving you data and context. Software and humans can navigate and browse the model to study the data, understand the data, and you can browse relations between objects, between types, etc. But OPC UA can also look like this. So this example shows that you can still use OPC UA to provide quite meaningless data. You can use OPC UA to provide data without any context. So just by installing OPC UA, that doesn't solve everything. So we, meaning the entire industry, need to agree on standardized information that we put into this OPC UA server. And the Lighthouse flagship project, where we started to use OPC UA at scale in Equinor, was in the Johan Sverdrup project. So this oil and gas field started production in October 2019, and this is one of the biggest oil and gas fields in Norway. And at peak production, this field alone will actually produce 30% of the total production in Norway. And OPC UA, to achieve interoperability, have been a central part of the digitalization strategy of this project since 2015 to 2016. And we have been working quite a lot with Predictor and other companies to succeed with this together, because driving business value and succeeding with OPC UA is not a one company show. We cannot do this alone. We need the industry to work together. So at this oil and gas field, we have 19 OPC UA servers that we aggregate into a central OT/IT gateway using the OPC UA aggregation architecture pattern to ensure that the IT platform have one endpoint to access all the information from Johan Sverdrup. And we stream around 200,000 real-time variables using OPC UA. So this means that we have proven actually that OPC UA works in practice at high scale. And when oil and gas is doing something, we do it by impact and scale. So many good things have been done here, but for me, this is not the end station. This is basically the beginning. So now it's time to improve, to evolve and scale based on all the learnings and work that we have done at the Johan Sverdrup oil and gas field. And by using OPC UA, we saw some simple, nice things. We saw that we can use a tool from supplier A to create information models in OPC UA. We saw that we can use a tool from supplier B to create the instances of that model. And we saw that we can use a tool from supplier C to actually connect to the model and browse the model that we have instantiated. And all this is done by plug and play. No hassle, no integration efforts, no plumbing, as Espen mentioned. It's plug and play. And people may take this for granted. It's a simple example, but in our industry, this is actually a game changer. We have so many incompatible systems in our industry that can't talk to each other. They can't exchange data with each other. And this leads to actually costly ways of working in our industry. And we cannot continue with this. It has to stop now. So plug and play over plug and pray. And in this project, the Johan Sverdrup project, we developed an OPC UA information model. Actually, we developed a library that is based on 10 years of experience we have on providing operational data from assets that you find on an oil and gas facility. So we created a library with around 50 different object types or over 1,000 attributes. And this model and this library that we developed there, we actually decided to make it open source, to make it available to the world freely. Because we truly believe that openness is the key to achieve adoption and to achieve impact when it comes to OPC UA standards and interoperability. If OPC UA was a closed standard, then it would have limited adoption and impact, in my opinion. So we need open standards, we need open ecosystems, we need open source. And we need solutions that companies can start to utilize quickly, lower the investment risk, lower the investment cost, make it as simple as possible to get started. And in Equinor, we have a very clear open source strategy. So our strategy in Equinor is that anything Equinor develops shall be made open source. That is the rule, actually. And OPC Foundation, OPC UA, for me, it's not only a connectivity framework, it's a community. And this community consists of people, it consists of companies that share the same beliefs, the same passion for interoperability, standardization, plug and play, make exchange of information easy. And we as an operator and end user, we benefit from this community. So by sharing something back, we believe we create a win-win for everybody. So everybody can now utilize and further improve and enhance what we have started on here. And that is the power of open source. As I mentioned, we have not achieved the end station. We have barely left the start station, I would say, and that is a quite ambitious statement because we have done so much great things already. But going forward, the next weeks, years, etc., We see a huge potential in usage and adoption when it comes to standardized OPC UA information models. There is a huge untapped potential there today. We see that we get a lot of OPC UA at the moment, but many of the models are not standardized. But luckily, many things are happening out in the industry now, as has been mentioned, VDMA, etc. Big organizations, machine builders, etc. They come together and create standardized information models. And the energy industry have a huge untapped potential here. We are also working on a closer integration between the plant floor and various applications and services in the cloud. It's very simple today to stream some telemetry data, some real-time data from the plant floor to the cloud, but very often we leave the context behind at the plant floor. So when we stream this data, we need to ensure that the applications and services in the cloud not only get access to the data, but also the information model, the context which originates at the plant floor. So that is something that we need to solve. And we are also looking into closing the loop between engineering and operations to ensure that all the models and knowledge built in the engineering phase can be reused and utilized in the operations phase. And this is about combining, because OPC UA is not the answer to everything. It's about combining other initiatives such as automation markup language for exchanging information in the engineering phase, combining that with OPC UA, and also the asset administration shell that we are looking heavily into. The asset administration shell is the standardized digital twin implementation in Industry 4.0, which is the picture behind me here. And that concept is also utilizing OPC UA, automation ML, REST APIs, making the same semantics available in a standardized manner to different mechanisms. And I also believe that more end users, the operators, need to have a consistent voice towards the suppliers when it comes to interoperability and usage of OPC UA. We sometimes hear that Equinor is one of the few companies that really push on this, and I believe that more operators should kind of strive for this, and I believe that the end users need to have a consistent voice towards the market. So to summarize my presentation, some key takeaways that I would like to share with you. Key takeaway number one is to actually seek help. Don't be afraid to ask for help, and to succeed with OPC UA, we have learned that we really need to invest in learning and understanding OPC UA. We need to educate ourselves. So to be a good end user and a good customer, we saw that we have to understand this. We need to understand what we talk about, and we need to understand what we actually require. So in the company, let the champions, let the advanced learners lead the way. And I also encourage all the participants here to share your story, share your experience, both the good experiences, but also the bad experiences on using OPC UA. Be open, share, and let's do this together. And the second key takeaway is that my story is actually not about OPC UA. The most important thing is that you need to have, or you need to find or spark the passion for interoperability, standardization, plug and play, collaboration. You need to have that passion. And this is what OPC UA is about. If you have that passion and you truly believe in this, you will find a lot of joy in OPC UA. If you don't like standardization and interoperability and you would like to do it your own way, then OPC UA will be painful. So it's not only about OPC UA, it's about striving for standardization and interoperability. And the third thing that I need to work on as well is to have stamina. I fully recognize and acknowledge that full adoption, full semantic interoperability across everything using OPC UA standardized information models, that will take time. that will not be done next week or next year. So this is not a quick win, but we cannot give up because of that. We need the stamina. We need to have a long-term horizon. We need a vision. We need to work towards that, but we also need to ensure that we step by step can provide business value here and now along the way. So that is a takeaway. Don't give up. Have stamina. And make sure that we can do things here and now and prove business value. So that was my presentation. It was a little bit strange presentation because the slides changed themselves. I guess you noticed that, but hopefully you got everything covered. So thank you.
Thank you very much, Stefan. We have a couple of questions for you. Let's see, the first one. Do you think OPC UA Part 14, which is report by exception, or do you think poll response?
Yeah, so in OPC UA, you have two communication models. You have a client-server communication model, which is the original one, the default one. And in the client-server communication model, you can subscribe to data by exception, or you can pull the data. Part number 14 is a second communication model, which is pub-sub, where the OPC UA publisher publishing data is decoupled from the subscribers subscribing to the data. We have been using OPC UA Part 14 in Equinor with success to publish data from the plant floor to the cloud. But it's important to know that pub-sub is not a replacement for client-server. We need both communication models for different use cases. So Part 14 is really elegant when it comes to streaming telemetry data to the cloud. But we still need the client-server communication model for the information models and other types of interoperability and use cases.
Great. Another question. Are your suppliers able to deliver data with standardized OPC UA models?
Some of them are, but very few at the moment. So as I mentioned, this is probably the biggest untapped potential at the moment. So we, and together with the suppliers, we need to agree on which standardized models that we need for given use cases. I also fully understand the suppliers because there are a jungle of models out there, but we in Equinor would like to help as much as possible together with the suppliers to ensure that we implement something that give value for both us but also the supplier. So simply, yes, some suppliers can do that today, but many suppliers are not there yet.
Good. We have a couple of more questions as well. Are you doing this for green fields only or also for brown fields?
Until now, it has been mainly green fields, but we also have employed OPC UA as a connectivity framework for certain brown fields as well. So OPC UA is a framework that is not purely designed for greenfield. You can easily implement this at brownfields as well, and the brownfields in Equinor, they are subject to modifications all the time. So when we do modifications on the brownfields, new technology will be implemented where OPC UA will come more or less out of the box. So this is not only something that we kind of would like to use on green fields as well. We also have some ideas on how to do this at brown fields.
Good, thank you. One more question here. What about use of OPC UA within the drilling and well domain? Does Equinor use OPC UA for that purpose as well?
Yeah, I'm not an expert in that domain. I think the drilling and well domain, they are a lot into this WITS ML standard, and I think they have their own protocol. But I also know that Energistics and OPC Foundation have collaborated on something there, but that is currently beyond my expertise.
Okay, thanks for that. Final question as well. What can other companies learn from you when it comes to implementing and scaling up usage of OPC UA?
Yeah, so some of the learnings that we see is that the decision when it comes to OPC UA in Equinor was not a big company top-down strategy from our CEO or something like that. It was driven bottom-up actually by personal champions, personal engagement. And you often need such champions. You need people with passion for standardization and interoperability, and let them lead the way before it becomes kind of the blueprint throughout the entire company. And a second learning is to get help and invest in learning. So OPC UA is not something that you learn in a couple of hours. Spend time, invest in understanding OPC UA, learn OPC UA. That's a key learning. And also an interesting learning is that when it comes to digitalization, you always hear this phrase that you need to think big, you need to start small, and you need to scale fast. But I used to say that at the Johan Sverdrup project, we were thinking big, but we started big and we scaled fast. So we actually made a bet on OPC UA here together with the suppliers on one of the biggest oil and gas developments in Norway for decades. And this was a flagship, not only in the Norwegian industry, but the global industry. And it turned out that OPC UA works. So when we have now proved that OPC UA works in such a major project, such a major operational field, we have learned that you remove any doubt in Equinor and in the supply chain on whether OPC UA will work or not. So when we started big and succeeded, that becomes the inspiration and blueprint for the following projects. So that is a key learning here, that yeah, at some point just do it big, and if you succeed, that will create impact. That's a key learning.